Good day. Today we are going to continue our lesson from last class. It's nothing but sorting. So can anyone give me the definition? We did see it last class. Okay, if not the entire definition, just the general meaning. I had an answer last time.
Order the objects in a particular.
Ordering, exactly. So it's nothing but, we said, okay, I'm just going to go over it again, just a review, and then we're going to see the other techniques we missed last class. Okay, so as he says, total order, anything that is ordered relative to everything else. That's nothing but sorting. And we saw the purpose. We said it's easier to sort. You'll know who your neighbors are. And we said you can nail out the duplicates. That is, if two items have the same value, you'll be able to sort them out. And techniques. We saw bubble. Okay, the techniques which we saw bubble sort and we saw insertion. So there are three more techniques which, if time permits, I'm going to cover all three. So the first thing is selection, there's merge, and there's quick sort. And before I continue, last class somebody asked me which is the best. I was a little premature in answering that question. I said merge sort is the best. The answer still holds good, but only under certain circumstances, not always. So I'll just give you a brief. When you have a huge volume of data and your data is stored in an external device, it is not in your computer, it's stored elsewhere, and you want to sort those kind of data, then you probably would use a merge sort because it's much more faster and it's efficient. Whereas the data is in your computer, be it large or whatever, if you use your internal memory to sort it, then quick sort is better. However, this is more simple, this is very complicated. But still there are cases where you would choose quick sort over merge sort. So I just want to elaborate on that a little. Is that clear? Okay. Now we are going to go selection sort. Today I'm not going to sort it. I'm going to tell you an overview and you guys are going to do it. You got to tell me what goes next. Okay? So selection sort is very simple again. So what you do, you take a particular element and you compare that with the other elements in an array. Let's say it's an array of integers, and you just find out which is the smallest, and then you make a swap. I'll do the first step for you. Give me some integers. Give me some numbers. Unsorted. 3. Okay.
1.
Sorry?
1.
Okay. Let me fill it up. Okay. So now how it goes. This is my selection point. I take my first integer and I'm going to compare this with every other integer in the group and I'm going to pick which is the smallest. So which is the smallest when you compare 3? 1. Okay. So once I find that, what I do a swap. Okay. So the sequence goes like this. 1, 3, 12, 13, 25. Unfortunately, we have an array which is already sorted. But this is how it goes. You take the second element and you compare, and if you find there's one more element which is smaller than what you have, the smallest, not the smaller, the smallest, and you again do a swap. So you continue doing this, you get a sorted array. Is it clear? Okay. End of class, I'll be giving you assignments. So if it's not clear, please do ask me questions. Okay. Now we're going to go to merge sort. As I said in last class, these two are very important. You can expect them on the quiz. Okay. So merge sort. The central feature for this, there's something called a merging step. So if you know what a merging step is, recursively you do that again and again, and ultimately you will have an array which is sorted. So I'm going to just tell you what a merging step is. You take two sorted sequence of arrays and you merge them into one single array. For example, you have 4, you have 7, you have 11. Let's say you have something here, 1, 3, 9, probably. Okay? Now what do? you take the smallest from this array, and you take the smallest from this array, and you compare those two. And whichever is the smallest, you put them in a new sequence. Okay? So, what do you think should come here? You're going to compare 4 and 1. What should come here? Louder! Okay. Now what you do, see, you compared 4 and 1, and you've engaged 1. Now you have 4 here. So what you do, from whichever array you have taken this 1 from, go there and take the next element. So you're going to compare 4 and 3. Okay? So what goes? It should come here.
3.
Good. And now what's the next element I should take?
9.
9 and 4. Correct. So I'm going to compare 9 and 4. So again, as you know, 4 will go here. Then you keep continuing this. Since 4 goes here, take 7. You compare 7 and 9. Blah, blah, blah. You do this. So you get the merging step. Now, I'm going to give you a sequence. And you're going to tell me how exactly the merge sort works. Okay. Since we're running out of time, I'm going to just help you out with the first step. The rest is an assignment. Okay? So, we said merge sort is something where you have to merge two different sequences. But when they give you an unsorted array, where is your sequence? So what you do, it's very simple. You consider each and every element as a single array. You consider 12 as 1, you consider like this. Everything is a single array. So all you have to do is perform merging step like this. Merge everything. So in the next, you probably will have only 2 arrays. Again merge them. And finally you will get a sorted array. So you are now doing nothing but merging it again and again. Okay? So that's it for today's class. To wrap it up, we saw selection and merge sort. So I said, if you compare merge and quick, there are circumstances where merge sort is more effective, and there are circumstances where quick is more effective. And the rest is your assignment. You will have to submit it on next class. Anything else?
Which one's gonna be in the quiz?
That you'll know when you get your quiz papers. Okay, thank you, class.